Hello everyone. In this lab demonstration video, I'm going to show how to calculate individual customers' lifetime values in Microsoft Excel. Before watching this video, please read the articles Blue Apron case and Otelunia case, and you can access those articles through our course pack. And please watch this instruction very carefully and create an Excel file that calculates the customer's lifetime value. And based on your calculation in Excel and previous lecture, you can answer the questions in the lab material, and then you can fill out your answer sheet with your answers. After watching the video and after the lab, please submit both Excel worksheet file and Word answer sheet file to our course website. Alright, and then let's get started. In this lab, we want to develop an Excel spreadsheet to evaluate lifetime value with various values of margin and retention rate, discount factor, and acquisition cost. And we have two different cases. One is Blue Apron case and the other one is Otelunia case. And we're going to make a separate worksheet for each of the cases. And let's start with the Blue Apron case. And you can download and open the spreadsheet file ltv.xlsx file. And you can access this file in the individual assignment webpage. In the file, there are two worksheets, one for the Blue Apron case and the other for the Otelunia case. And this is the shape of the worksheet for the Blue Apron case. This is quite simple, right? And all of the information necessary to compute lifetime value is given in this worksheet. And just let me quickly summarize of the information. First, discount factor. This is called WACC, weighted average cost of capital in the article. And 1.53% of discount factor is used in the case. This is equivalent to 20% of the annual discount factor. That means when we multiply this discount factor plus 1 12 times, we may get 1.2, 120%. So let's just double check it. Put the equality sign and then open a parenthesis and put 1 plus 1.53%, which is the same as 0.0153, and close the parenthesis. We're gonna multiply these 12 times, so place this head mark and 12. Then press enter, then you have about 120%. That is 20% annual discount factor. And the next information is the acquisition cost, which is called CAC, Customer Acquisition Cost in the article. And in the article, it is given on average $100 per customer. And the next information is the margin. The margin is denoted by M in the article, and the margin is assumed to be on average $26.8 per customer. And let's move on to the retention rate, which is denoted by R in the article, and the customer's actual retention curve over time is given in the article. The curve implies that there may be two segments of customers. One is high loyalty segment, the other is low loyalty segment. And based on an estimation, high loyalty segment takes about 46% of the customer base, and its retention rate is estimated to be 92.3%. And low loyalty segment takes 54% of the customer base, and its retention rate is estimated to be 43.4%. So we have two different segments, and we are going to compute the lifetime value for each segment. After that, we are gonna compute the weighted average of the lifetime value as the overall lifetime value per customer. Okay, let's do that. To compute the lifetime value of high loyalty segment, just recall the lifetime value equation. The lifetime value is given by the contribution margin times a multiplier, which is given by retention rate divided by 1 minus retention rate plus the discount factor. And then we need to subtract the acquisition cost from the net present value, and that is the lifetime value. And if you want to see the equation of the lifetime value again, please refer to the page 3 in our lab material. Alright, and then let's just implement that equation in Microsoft Excel. So click this cell B7. And I'm going to compute the lifetime value for high loyalty segment. So to do that, put the equality sign. And first we need to get the contribution margin. So click cell B5 where the contribution margin for high loyalty segment is. And times, open a parenthesis. The next one is retention rate. And retention rate for high loyalty segment is in cell B6. So click B6. And it is divided by 1 minus the retention rate plus the discount factor. So we need to open another parenthesis and put 1 minus retention rate. Click the retention rate again and plus the discount factor, which is in cell B1. But this discount factor is fixed for all of the segments, so we need to put the dollar mark before the column number and the row number. So place dollar mark here and here and close one of the parentheses and close the parenthesis again. So we put the multiplier here and we need to subtract the acquisition cost from this net present value. So put minus sign and click this acquisition cost cell. That is B2. And again, this acquisition cost is fixed for all segments. So we need to put the dollar mark again here and here. So that's the final equation of the lifetime value for high loyalty segment. And just press enter. And you can get the lifetime value for high loyalty segment, which is $168. Now we just need to repeat this for low loyalty segment. To do that, you just need to copy this cell and paste it into this cell, right? So click this cell and copy by pressing Command C or Control C and click this cell and paste the equation. And you can see the lifetime value for low loyalty segment is about minus $80. So it means that for each customer in low loyalty segment, this company, Blue Apron, makes a loss per each customer in this low loyalty segment. Then we need to compute the overall lifetime value. To do that, we need to compute the weighted average of the lifetime value. Why? Because the segment size is different between the high loyalty segment and low loyalty segment. High loyalty segment takes only 46% and low loyalty segment takes 54%. So we need to consider this weight to compute the average lifetime value. So to compute the overall lifetime value, we are going to use some product Excel function. So click this overall lifetime value cell and put the equality sign and sum product, open the parentheses. This function has two arguments, each of which indicates an array of numbers. So the first array is given by the lifetime values. So select these two cells and press comma, and the next array should be the segment size. So select the segment size cells and close the parentheses. And that's the Excel equation to compute the weighted average of the lifetime value. And let me explain a little bit more about this function. This function returns the sum of the product of elements corresponding to each other. So that is, this function with these two arguments first compute the product of B7 and B8, which are the first element of the first array and the second array. And then this function compute another product of the second element from the arrays, that is product of C7 and C8. And then this function compute the sum of those products as the return value. So press enter, then you can get the weighted average of the lifetime value of a Blue Apron customer. That is $34. And that's it. Very simple. And just in case, please save your worksheet. And now I think you can answer the questions in the lab material. Okay, now let's move on to the Otelunia case. And in our second worksheet, you can find a worksheet of the lifetime value for three different groups. And again, all of the information required for computing lifetime value is given in this worksheet. And let me quickly summarize all the information. In this case, 0.0261% of the daily discount factor is used. This is equivalent to a 10% of the annual discount factor. That is, when we multiply 1 plus this discount factor 365 times, and then we may get 110%. And let's check it. So put the equality sign and open the parentheses and place 1 plus 0.00261, which is the same as 0.0261%, and close the parentheses. And we are going to multiply these 365 times, so put this head mark and 365 and press enter. Then it's about 110%, which is the same as 10% annual discount factor. And the next one is the acquisition cost. In the article, the acquisition cost is reported as CPI, cost per install, which is ranged from 140 Japanese yen to 180 Japanese yen. So we are using the average, which is 160 Japanese yen as the acquisition cost. And in this case, the margin is not directly given in the article. Instead, we can compute an expected average revenue per user. This is about the mobile game, so any variable cost per user may be negligible. So the expected average revenue per user can be used as a proxy of the contribution margin for each customer. And let me explain how to compute the expected average revenue per user from the information given in the article. So let's think about there is a user acquired in a week. This user can be a light user, and can be a moderate user, and can be a heavy user. Regardless of type of this user, the computation does not change. So just let me illustrate the computation of the expected average revenue only for the light user. You can just repeat the same thing for the moderate users and the heavy users. And a light user acquired in a week can be a non-paying user and a paying user. And in the article, the percent paying users is given by 0.6%. It means that with the probability of 0.6%, this light user acquired in a week would be a paying user. And if this user is a non-paying user, we don't need to think about this user because non-paying user does not make any revenue. So the expected revenue from this type of a user is 0. And a paying user plays a game with the probability of the number of play days in a week divided by 7. So a light user is known as to play this game only one day in a week. The probability of this user playing a game in a specific day is given by 1 divided by 7. That's the probability of playing a game in a day. And the other days, this user is expected to not play the game. So this is the only case where the revenue is generated from this user acquired in a week. And then, what's the probability? That is, percent paying users times the number of play days in a week divided by 7. That's the probability of revenue generated. Then, we just need to multiply the average revenue per paying user, which is given in the article, by the probability of revenue generated. And then that is the expected revenue per this light user. And we can just repeat the same thing for a moderate user, a heavy user. Okay? And we are going to implement this equation in the Excel spreadsheet to compute the contribution margin. Okay? So for each segment, we have the information about the average revenue per paying user, ARPPU, and percent paying users, PPU, and the number of play days in a week, MPDW. And this is the equation we need to compute for contribution margin for each segment. So we just need to implement this. To do that, just click cell B8 and put the equality sign. And where is ARPPU for the light user? Cell B5. So click B5 times percent paying users for the light group. That is cell B6. So click B6 and times, open the parenthesis, and where is MPDW, the number of play days in a week? That is cell B7. So click this cell and divided by 7 and close the parenthesis. And that's all. Just press enter. Then you have the contribution margin for the light user. That is 1.11 Japanese yen. Very small. And you can repeat this for the other segments. To do that, you just need to copy this cell and paste it in the cell for moderate group, that is C8, and the cell for the heavy group, that is cell D8. And you have the contribution margin for the moderate group and contribution margin for the heavy group. Then the remaining job is very straightforward. You just need to repeat the same thing as you did for the Blue Apron case. So I'm not going to show how to compute the lifetime value for each segment here. And then I'm not going to show how to compute the overall lifetime value each your assignment. But don't forget, you have 3 groups, not 2 groups in this case. So you need to be careful when you use the sum product function to compute the overall lifetime value. Alright, that's all I have for the lab. And I strongly believe you can compute the lifetime value and the overall lifetime value for the Otelunia case, and then you can correctly answer all of the questions in the lab material. Alright, bye-bye.